Okay, so our first part is the Pythagorean Theorem. We're using a squared plus b squared equals c squared. We substitute in our legs. Remember, c is our hypotenuse, the side opposite of our right angle. And here we actually have that labeled exactly. So c squared, biggest side, going to be our hypotenuse. So now we substitute in 6 squared plus 8 squared. 6 squared is what value? 36. And 8 squared is? When I add those two together, what value do I get? 100. 100 equals c squared, and Rio already told us when we square root both of those, we end up with c equals 10. Rio? 10? Okay. The next one is still Pythagorean Theorem, but now we have our c squared value. So remember, c squared is the one directly across from our right angle. So we end up with 15 squared equals a squared plus 12 squared. So 15 squared. Anybody know that one? So if we are unsure, we're going back from back here. Yep. So you end up with 225, which would be correct. So we have 225 here equals a squared plus, you told me what? 144. Subtract 144 because we're combining our like terms, and our like terms are things that are not going to be our variables, so the constants. As we subtract this, what value do I get?
81.
81. A squared equals 81. So we're going to square root both sides to solve for A. A equals what? 9. It's a perfect square. If you did not remember that they were perfect squares, you could go through our tree, circle the ones with buddies, and it would end up being 9. Okay, now we have isosceles triangles. We see we have two angles that are congruent. The sides opposite of congruent angles are congruent. So we can set 24 equal to 2x plus 8. So 24 equals 2x plus 8. Combine my like terms, which are my constants. So I'm going to subtract 8. When I subtract 8, 24 minus 8. 16 equals 2x. Divide by 2. X equals 8. Okay, our next two you now see of congruent sides. Angles opposite of congruent sides are congruent. So we know that 47 is going to equal 5x minus 18. We're going to add 18 to both sides because it's what doesn't have an x. What'd you say it was, hon? Yep, 5x equals 65. We're going to divide by 5. And x equals 13. Nice job. So right here, we're going to use the Pythagorean Theorem to solve these. So a squared plus b squared equals c squared. Oh. Okay, so our first part here is the Pythagorean Theorem again. The same thing with all of them. We end up with a squared plus b squared equals c squared. Our c value here is going to be that x, exactly right. And we have 8 squared plus 8 squared equals x squared. Exactly right. 64 plus 64. 128. Okay, now that we have this, we're going to square root both sides. Is 128 a perfect square? No. So we're going to go through and look at our factors. What goes into 128? 2 goes in. So that's going to leave me with 64. 8 and 8. 64 is a perfect square. If you want to keep going, you can, but I already got something that has a buddy. I can circle my 8s. It's going to be 8 comes out because it has the buddy. You guys just flipped it. 8 radical 2. So x equals 8 radical 2. If you're over there having a conversation, please end it. Okay, now we see here it doesn't have an x, but we're solving for it anyway. So let's take a second, see if we can get to where he got. You end up with x squared equals 4 squared plus 4 squared. We end up with x squared equals 16 plus 16. X squared equals 16 plus 16 equals what? 32. Square root both sides. This goes to 2 times 16. 16's factors 2. 4 and 4. 4's have a buddy. They get to come out. X equals. Okay, over here. we end up with x squared equals 5 squared plus 5 squared. X squared equals 25 plus 25. X squared equals 50. So resuming, we have 50. 50 factors into 2 and 25. 25 factors into what? 5 has a buddy. It comes out. We end up with 5 square root of. Nice job. And our last one, we have x squared equals 3 squared plus 3 squared. X squared equals 9 plus 9. X squared equals 18. 2 times 9. 9 goes to 3. Okay.